All right, so we're going to talk about the limit definition of the derivative. There's actually a few limit definitions of the derivative, but this is the general one for a general x that we're going to use here. So given that we have a function f of x that is differentiable, we define the derivative of f of x as follows. So we have the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Okay, so this is the formal definition, and this is, I'll do a basic diagram of what's happening here and why this should be the definition. So suppose we have some function here, and the function will look maybe something like this, and so let's say we're looking at some particular x value here. Well, what we're going to do is we're going to have some little offset, call it delta x, like this, and then when we calculate this, we're really calculating the slope of the following line, right? The line that runs through x and then x plus delta x and the function values. So as we shrink delta x, so that's what this limit here means. It means that the delta x is going to 0. This point is getting slid back to this value, and this line, which is called the secant line, eventually becomes the tangent line, and will have the slope at exactly our particular x value. So we can do a very basic example of this. Let's consider the function f of x equals x squared. Okay, so when I do mine, I really like to use h instead of delta x to keep things from getting confused. So we'll write out our definition. Limit is h goes to 0 of f of x plus h minus f of x over h. All right, so I like to calculate this piece first, the f of x plus h, as a side calculation. So if I do that, f of x plus h is really x plus h squared, which we can write out in its expanded form like this, and then FOIL it out, x squared, xh, xh, h squared, and combine our terms, x squared plus 2xh plus h squared. So this expression goes here, and f of x is just f of x. So for mathematical rigor, we should copy our limit sign and copy in our parts. So here, f of x plus delta h is x squared plus 2xh plus h squared minus f of x. F of x is just x squared, and our denominator is just h. So if we simplify the top, we just have 2xh plus h squared over h, with a limit as h goes to 0. All right, well, if we look, we can factor out an h in the numerator, and these h's reduce out. So we're left with the limit as h approaches 0 of 2x plus h, but this h is going to 0, so we just have 2x. All right, and that is the derivative of x squared. All right, so this is a basic example of how to do the limit definition of the derivative. We can do more complex examples in another video.